Hi, welcome to another edition of Engineering with LEGO Bricks and Robolab. I'm Eric Wong, and I'll be your host. Containers. This is one of the confusing things for students when they first start programming. If you've used another programming language, a container is basically a variable. So if you ask the question, what is a container? It's a variable. And if I wrote an expression, for example, if I took this expression and said x equals 10, I think most students understand that I could use an algebraic expression where x is a variable. And I could also probably understand that if I said if I had a variable, I could also use it on both sides of the equation. I could say, for example, x equals x plus 1. So if x was currently 10, and let's say x equals x plus 1, well, the new value of x will be 11. I think most students can follow that. And that's pretty typical of a programming language where x would be the name of the variable, and we're operating on a variable on the left-hand side of the equation here. We're operating on the variable, or I'm defining what variable I'm using, x, and on the right-hand side, I'm using, for example, here I'm using the current value of x, and be saying this would be the new value of x, and this is the old value of x, as an example. Robolab is no different, except that we can't name the variables x. We're stuck with containers. We're stuck with colors, red, blue, and yellow. So we actually do have more if you want to use more than just red, blue, and yellow, but that's typically speaking is we're using red, blue, and yellow. So you can't call them x. That's the only difference here. So this is the exact same program done in Robolab. Where I'd start here, I'd say, well, let's fill the red container with a value of 10. That's what this little function is here. Taking the red container and a value of 10. That's the same as saying x equals 10. Well, the red container equals 10. Then I'm saying here, well, take the value of x and add 1. So take the red container and add 1 to it. Add 1 to the red jar, red container. So I'm just saying, well, whatever x is 10, now it's 11. So this is equivalent to an operation where you see in code where variables normally x, maybe time, whatever, distance traveled would be the variable name. Here we're stuck with red, blue, and yellow as the variable names. That's just the way it is. And so that's basically what a container is. Now I'll scroll down here a little bit more. I can have more than one program. Don't try this at home because it actually doesn't work when you go to download. It only download one of the programs to your RCX. So although you can write more than one program, it won't give you an error. It'll only download one of them. But for my video here, I'm just going to use them all on the same page. And so here is the idea: what's a container versus a container value? So if I go to my modifiers palette, you'll see here this red, blue, and yellow container. That says what container am I operating on. I'm operating either on the red container, the blue container, and the yellow container. And on the right-hand side here, you'll see the same things, red, blue, and yellow containers, but they've got these little blue outlines. These are container values. So containers, container values. What's the difference? That's the next question on my agenda. Well, here's a little operation. So the program starts, fills the container with the value of 10, so x equals 10. And it says wait for, in this case, 10/100ths or 0.1 seconds. Very silly program, but it gives you an idea. And so when I'm operating on a container, I use the container itself, so the red, blue, or yellow. When I want to use what's in the container, so I want to operate with a container, I have to use the container value. So if I want to use what's in the container, I want to operate with that container, I have to use the container value. If I'm operating on that container, I'm going to use this big brown wire versus the little tiny skinny blue wire. So that's really the difference between a container and a container value. That's a little bit of semantics there, but it makes a big difference. Okay, so let's see one more example here about integer math, because it turns out that containers are integer values only. So it will drive you crazy a little bit. I guarantee this will go to haunt you at some point in time. So I've got a little math here it's going to do. Let me actually close this so we don't need this anymore. It's going to come in here and it says by default, I don't have the containers on here, but by default it's going to do the red container. So the red container filled the value of 3. I'm going to divide the red container by 2, and I'm going to multiply by 2. Well, it turns out that it's an integer value, so filling the value 3 is 3. Divided by 2, 3 divided by 2 is normally 1.5. Now, because it's integers, you can't have a floating point number. 1.5 is a floating point number. So 1.5 is rounded to 1. It doesn't round up, it doesn't round down, it just truncates. It gets rid of every decimal place. So 1.9999 is 1. 1.01 is 1. 1.5 is 1. So 3 divided by 2 is 1.5, so it rounds out to 1, times 2 is 2. And now I'm going to show here, this just displays the value of the red container for 4 seconds to the LCD. So it'll show 2. 3 divided by 2 times 2 is 2. That'll drive you crazy. The thing that usually drives students crazy is if you get something like 1 divided by 2. 1 divided by 2 is 0.5 is 0. And then you can do whatever the heck you want, multiply, divide, and 0, you end up with 0 in the end. So zeros drive you nuts, because once you get a 0 in your equations, usually the answer is going to be 0. So you got to be wary that it is integer math, and I guarantee you at some point in time it'll come bite you in the butt, because it is integer math. Now the only last thing I want to note is that the largest number you can store in the RCX in a container is 32,768. 2 to the whatever that is. So you can store negative that value, negative 32,768. You basically have 64,000 values. Negative 32,000 and positive 32,000. Those are the largest numbers. So if I take 32,000 and I add 32,000, the answer is 32,768. That sounds very strange, but that's true. It'll round to the largest number. Okay, just be aware of those various things. Another thing is basically, another hint is basically do all the multiplications first. If I had reversed this order and done 3 times 2 divided by 2, I would get 2, or I get back 3. Yeah, I can do my math. I get back 3 like I'm supposed to get. So if you do the multiplications first and divisions last, that's a usually good thing.